Dear children, today let us begin the third chapter, Rotation and Revolution. The Earth, like all other planets in the solar system, revolves round the Sun in an elliptical orbit, and it also rotates on its axis. These two motions of the Earth are known as revolution and rotation, respectively. Many phenomena on Earth, like day and night, seasons, winds, and ocean currents, depend on these motions. Rotation of the Earth. Definition of rotation. Rotation is the spinning of the Earth on its axis from west to east once in 24 hours. The axis is the imaginary line passing through the center of the Earth as it does on the globe. The two endpoints through which the axis passes are known as the North Pole and the South Pole. The axis is tilted at an angle of 23.5 degrees from the vertical. This means that if a line were drawn parallel to the plane of the Earth's orbit, the axis would make an angle of 66.5 degrees to this line, which is shown in the picture figure 3.1. Characteristics of rotation. First one is direction. The Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes, 4.9 seconds, roughly in 24 hours. The second characteristic feature of rotation is inclination of axis. The Earth is always tilted in the same direction towards the pole star as it moves round the Sun. The angle at which the Earth is tilted is known as the inclination of Earth's axis. Third one is speed. The speed of Earth rotation at the equator is 1670 km per hour. Circumference of the Earth is 40,070 km, which is covered in 24 hours. The speed decreases towards the poles. Effects of rotation of the Earth. First one is occurrence of day and night. Occurrence of day and night are caused by the rotation of the Earth on its axis. This is because parts of the Earth which face the Sun have day, and the parts which do not face the Sun have night. This happens with precision and progression, and not suddenly. The time when the Sun begins to cast its light in the sky is known as dawn, that is early in the morning, before the sunrise. At noon, the sun is overhead. At dusk, it is twilight. It is in the evening when the sun sets and the sun is seen disappearing in the sky. At night, it is completely dark. Duration of the day and night is not equal at all places on the earth because of the inclined axis. The length of the day varies with respect to the seasons as well as latitude. The second effect is sunset. These are caused by the rotation of the earth from west to east. This happens because due to the earth's rotation, every part of the earth's surface faces the sun at some time or the other. The part of the earth that moves from darkness into the sun's rays experiences sunrise, and when it moves away from the sun's rays, it experiences sunset. Third one is Coriolis effect. It refers to the force experienced by any object moving over the surface of a rotating body such as the earth. The Coriolis effect plays an important role in the movement of air, that is winds, and water, the ocean currents, on the earth. Due to its effect, The winds and the ocean's currents move clockwise and are deflected to the right in the northern hemisphere and move in the anticlockwise direction and deflected to the left in the southern hemisphere. The fourth one, the sun, the moon, stars seem to move from east to west. This is because the earth spins from west to east. This effect is similar to what one experiences while looking at trees from a moving train. Fifth one is centrifugal force. It is an apparent outward force that acts on a rotating object. It is always directed outward, that is, away from the axis of rotation. The speed of rotation has created a centrifugal force resulting in a bulge in the middle portion of the earth and a flattened top at the poles. Sixth one, rotation causes difference in time over various places on earth. The difference in time is 4 minutes for each degree of longitude divided 4 hours divided by 360 degree. Seventh one, the side of the earth towards the sun constantly gains heat and the side away from the sun constantly loses heat by radiating it into upper space. In this respect, rotation of the earth in a tilted position on its axis has the following advantage. The first one is the short rotational period makes the variation of temperature between day and night moderate. Second one, rotation in combination with revolution, Earth's movement round the sun, causes season and variations in the length of day and night over different places on Earth. Inclination of Earth's axis and its significance. As we have said, rotation is the spinning of the earth on its axis from west to east. The axis is the imaginary line passing through the center of the earth on which it rotates. The earth's axis is not vertical. It makes an angle of 23.5 degree with the vertical or 66.5 degree with the plane of the earth's orbit. Let us imagine that the earth had a vertical axis, then all the places on the earth, the length of day and night would have been equal as shown in the figure 2. The effect of the inclined axis on the duration of day and night is that the duration differs from equator to North Pole and equator to South Pole. During the summer season, the duration in the northern hemisphere is 12 hours from the equator to 24 hours in the northern hemisphere, and 12 hours from the equator to southern hemisphere it is 0 hours. During the winter season, when the south pole is tilted towards the sun, the duration of daylight is 12 hours from equator to 24 hours to the south pole, and from the equator 12 hours to north pole 0 hours. This happens because of the tiltation of the earth's axis. Effects of the inclined axis on the duration of day and night. The duration of day and night is not equal at all places. The time of the day at any place is determined by the height of the sun in the sky. If the axis of the earth was vertical instead of inclined, places on earth would have the same temperature throughout the year. If the earth did not revolve around the sun, even then, with its inclined axis, there would be no seasons. Effects of the inclined axis on seasons. The path of the earth around the sun is known as elliptic. It passes through the center of both the earth and the sun. The Earth's axis is not perpendicular to the plane of the ecliptic, but is tilted at an angle of 66.5 degrees to it. The axis is therefore inclined at an angle of 23.5 degrees from the perpendicular to this plane. As a result of this, in the course of the Earth's movement around the Sun, the North Pole remains inclined towards the Sun part of the year, while the South Pole is tilted away from it. For the remaining part of the year, the situation is reversed, the North Pole being tilted away from the Sun and the South Pole being inclined towards it. On Earth, this gives rise to the changing seasons and the varying length of day and night. If the Earth's axis were perpendicular to the plane of the orbit, there would be equal nights and days at all places on the Earth, at all times of the year, and there would be also no seasons. Tilted axis and revolution of the Earth create heat zones, which is explained in the later in this chapter. Revolution of the Earth. The Earth revolves round the Sun in an elliptical orbit. This motion, together with rotation, makes Earth's environment complex. Characteristics. The first one, the Earth moves round the sun in an elliptic orbit at an average speed of 29.8 kilometers per second, or about 1 lakh kilometers per hour. Second one, when the Earth is closer to the Sun, the gravitational pull makes the Earth move faster than when it is away from the Sun. Thus, the speed of revolution is not uniform. Third one, the period taken by the Earth to make one complete round of the Sun is 365 days, 5 hours, 48 minutes and 45.51 seconds, which is taken as 365 days and 6 hours. The length of the one solar year is 365 days. The remaining 6 hours are adjusted every 4 years into one complete day and added to the month of February. When February has 29 days, that year is known as a leap year, having 366 days. Fourth one, the Earth's axis is always inclined to its orbital plane at an angle of 66.5 degrees. The motion of the Earth is from west to east, or in the same direction as the rotation. Effects of revolution. First one, seasonal changes. The amount of heat that a place receives on Earth depends on the angle at which the sun's rays reach it. When a place receives vertical sun rays, the place gets hot. This is because the amount of heat in the direct vertical rays is concentrated on a small area, whereas the same amount of heat is spread over a larger area in the case of the oblique rays. We have already noted that the tilt of the Earth's axis causes the seasons. Revolution causes different seasons, that is, the changing weather conditions due to differences in the heating of the Earth. Revolution is an annual cycle, so the seasons repeat year after year. The second one, inclination of axis and seasonal changes. Since the Earth is tilted, the seasonal changes are not abrupt or sudden. Third one, perihelion and aphelion positions. The Earth's orbit is the path along which the Earth travels around the Sun. This path is elliptical in shape. Due to this elliptical orbit of the Earth, the distance between the Earth and the Sun varies. When the Earth is closest to the Sun, the position is called perihelion, and when it is farthest, the position is called aphelion. At aphelion, the distance of the Sun is 150 million kilometers, while at its closest at perihelion, the Earth is 147.3 million kilometers away from the Sun. Owing to the elliptical orbit, The minimum distance of the Earth from the Sun is reached on or about January 3rd every year. It is winter in the northern hemisphere when the axis is tilted away from the Sun. While the tilt makes the northern hemisphere cool in winter, its comparative nearness to the Sun helps to make the southern hemisphere warm in summer. On January 3rd, the Earth in its orbit is closest to the Sun. This time of the Earth is said to be perihelion. On about July 4, the Earth is farthest from the Sun. At this time, the Earth is said to be aphelion. Fourth, creation of heat zones. The spherical shape of the Earth along with its movements around the Sun causes the difference in the angles at which the Sun's rays fall on the Earth's surface. This causes difference in the distribution of heat on the Earth's surface. As a result, the world has been divided into three distinct heat or temperate zones. The first one is the torrid zone. This zone stretches between 23.5 degrees north and south latitudes and more or less receives the vertical rays of the Sun. As a result, this region experiences moderately warm climate throughout the year. The second zone, the temperate zone. In between the torrid and the frigid zones, that is between 23.5 degrees north and south and 66.5 degrees north and south, lies the temperate zone. In this zone, the Sun's rays fall obliquely and hence the region experiences a moderate climate. Third one, the frigid zone. This zone extends from 66.5 degree north to 90 degree north and 66.5 degrees south to 90 degrees south. Since the Sun's rays fall extremely oblique in this region, the region experiences extremely cold. Solstices and equinoxes. The lighted part of the Earth is called the circle of illumination. This circle moves with the apparent movement of the Sun, so that only half of the Earth faces the Sun at any given point of time. First one is solstice. On June 21st, the Earth is in the position where the North Pole is tilted towards the Sun. On this day, the Sun is overhead at the Tropic of Cancer. This day is known as the summer solstice. The southern hemisphere, however, is tilted away from the Sun and experiences winter season. On December 22, the southern hemisphere is tilted towards the Sun, while the northern hemisphere is tilted away from the Sun. This day is known as the winter solstice. It is summer in the southern hemisphere and winter in the northern hemisphere. Second one is equinox. On 2 days in a year, the Sun shines vertically over the equator, that is, at an angle of 90 degrees. This angle decreases as one moves away from the equator. These days are 21st March, that is spring or vernal equinox, and 23rd September, that is autumnal equinox. At the equinoxes, the days and the nights are of equal length throughout the world. On 21st March, it is the spring in the northern hemisphere, and on 23rd of September, it is autumn. The position is reversed in the southern hemisphere. At the two equinoxes, the Sun is at 90 degrees at the equator. As one moves away from the equator, the altitude of the Sun decreases. Apparent northward movement of the Sun continues up to June 21st, that is summer solstice. There are variations in the duration of daylight. Angle of incidence and duration of daylight. The angle of incidence of Sun's rays and duration of daylight differs from lower latitude to higher latitudes. The altitude or the angle of incidence is also measured in degrees. It is calculated by subtracting the value of the latitude in degrees from 90 degrees, the maximum reached at the equator. For example, in the above table 66 and 30 degree north latitude, the angle of incidence would be 90 minus 66 and half degree north. That is, and the answer we get is 23 degree 30 minutes. Similarly, if a latitude of a station were only 60 degree, the angle of incidence would be 90 minus 60, it will be 30 degree. Kindly go through the table, dear children. Cycle of seasons. The equinoxes and the solstices are the positions of the earth with respect to the sun on the given fixed dates. They help us to understand how seasons occur and how they are reversed in the northern and southern hemisphere. When it is summer in the northern hemisphere, it is winter in the southern hemisphere. The variations in the altitude of the sun during equinoxes and solstices in different latitudes, it is observed that the duration of day and night varies according to the seasons. As a result of these variations, seasons are not the same in all parts of the earth. In general, there are 4 seasons: spring, summer, autumn, and winter, corresponding to the dates of solstice and equinox. Position on 21st June. It is summer solstice in the northern hemisphere. The rays of the sun fall vertically on the Tropic of Cancer. The duration of sunlight or daytime increases from 12 hours at the equator to 13 hours and 27 minutes at 23.5 degree north, and further to 24 hours at 66 degree and half degree north. Beyond the Arctic Circle, the region experiences 24 hours of daylight. This phenomena is termed as midnight sun. Norway is called land of moonlight, sun, and many tourists flock to Norway to witness this phenomena. The sun is visible only at very low height, just above the horizon. This continues for almost 3 months up to autumn equinox. In the southern hemisphere, it is winter. After 21st of June, the hours of sunlight in northern hemisphere begin to decrease from 12 hours at the equator to all nights and no days beyond the Arctic Circle. This position can also be observed. The maximum position is reached on December 21st. Position on 23rd September. On 23rd September, the sun is vertically overhead at the equator and the days and the nights are equal. It is autumn in the northern hemisphere and spring in the southern hemisphere. On September 23rd, the duration of sunlight is 12 hours on all places on earth. Position on 22nd December. On 22nd December, the southern hemisphere is tilted towards the sun. It experiences summer. Areas beyond the Antarctic Circle experiences 24 hours of daylight. Being a water hemisphere, the spectacle of the midnight sun, though more interesting, is confined to navigators only. The south polar region has 24 hours of sunlight continuously for many days. It is summer in the southern hemisphere and winter in the northern hemisphere. Position on 21st of March. After 22nd December, the sun again begins to move towards the equator, and on March 21st, the sun's rays fall vertically over the equator. On this day, all places on the earth have equal days and nights. It is a repeat of the position of 23rd September only in reference to the duration of day and night, but not in reference to the seasons or weather. During this period, it is spring in northern hemisphere and autumn in the southern hemisphere. Twilight in low and high latitudes. It is clear that there are generally great seasonal contrasts as one moves from equator to the poles. The variations in the amount of heat received at different parts of the earth during the year depend on the inclination of Earth's rays. The difference, though, is best explained by vertical and slanting rays of the sun. We should also remember that no place on earth has abrupt change from vertical to slanting rays, or vice versa. During sunrise and sunset, though the sun is below the horizon, we experience a diffused light. Much of this light is a reflection by clouds and dust particles present in the atmosphere. This period of diffused light between sunset and complete darkness is called dusk or twilight, and that between sunrise and the full daylight is called dawn. This phenomena of dawn and dusk is experienced more in temperate regions. Duration of twilight has considerable influence on seasons. The duration of twilight is large beyond 50-degree latitude, and in polar region twilight lasts for as much as 7 weeks at a stretch. The twilight continues as long as sun is 18 degrees below the horizon. Its duration is 1 hour and 12 minutes at the equator. It goes on increasing towards the poles. At the poles, the duration is 50 days long during the 3 months of alternating period of the day and night. This is because the period during which the refracted light is received at the equator is short, as the sun rises and sets in a vertical path there. On the other hand, in temperate latitudes, the period of refracted light is longer, as the sun rises and sets in an oblique path. It is much longer at the poles. That is why the winter darkness there is only twilight.